This video is designed to teach you a little bit about GRE and GMAT math instruction. While the verbal sections of the GRE and the GMAT are somewhat different, the math sections are substantially similar. This is why we offer our foundations class as a sort of bridge. It is GRE/GMAT Math 1 Foundations. It covers the basics of mathematics for both tests, in addition to the level 2 math classes that are separate and specific to each test. So the foundational skills are going to include arithmetic and number properties, algebra, geometry, probability, statistics, and data analysis. There's no calculus, no trigonometry, nor other higher order mathematics necessary. Most of our math students have not touched these subjects since they graduated from secondary education. As such, the Math 1 class is very useful for students who do not know English language math vocabulary, like integer and improper fraction, as well as those who've forgotten things like the arithmetic order of operations and so forth. Most of the essential information to memorize is distilled here in the memorization chart. This chart is also on AEI data, and I'm going to actually switch over to the Excel spreadsheet now and move our little screen over here so we can take a closer look at these points. I strongly encourage students to turn these into flashcards. Now on campus we do have a Barron's box full of GRE math flashcards. These are phrased, all of them, as questions. What is an integer? And then it gives definitions and examples on the back. What are sum, difference, product, and quotient? Again, with definitions and examples on the back. But I handmade my own little example flashcards for formulas. What is this? Keywords for word problems. So what word in a word problem tells me to add, subtract, multiply, divide, to use an equal sign, to use parentheses, or to use an integer, as well as the turnaround words that tell us to reverse the order of operation in subtraction and division problems. I have 3, take away 2 is 3 minus 2. But if I have I'll show you in a minute when we get to that. It'll be easier with the example on screen. And then the other thing I have as flashcards is numerical equivalencies. And so on this, for example, I have on one side 0 squared and on the reverse side 0. Because memorizing that with the same kind of automaticity that we expect of students with their English language words in just speech, reading, writing, and listening is also going to be important at improving their speed on the math section of the test. So I've got those numerical equivalencies listed here on this memorization sheet. I encourage you to tell students to actually make their own little handmade flashcards because it will help them to memorize faster, and that being faster at having it memorized means they'll be faster on the exam too. So that includes your square numbers, the equivalent proportions between fractions, decimals, and percents. And I'm going to scroll. We also have the first 10 factorials, equivalent values of your square roots. And I want to point out there's a really interesting pattern here. What happens is they increase after the square root of 3, they go up in units of about 0.2. So square root of 4 is 2. The square root of 5 is about 2.2. Square root of 6 is about 2.4. Square root of 7, approximately 2.6. Square root of 8, approximately 2.8. Square root of 9 is exactly 3. And the square root of 10 is almost 3.2. So let me erase all of those little marks real quick so we can move on, and I'll show you some other parts of the chart. Let me turn off the annotation tool. No, just turn it off entirely. Thank you. Okay, stop. Go away, everything. Will it let me remark on this now? Okay, now I can't escape this tool. Okay, now I've got my controls back. Sorry, I'm new to Screencast-O-Matic. All right, so other things they will need to memorize in arithmetic will include the nature of even and odd numbers in addition, subtraction, multiplication, division. We also have algebra, first, outer, inner, last, and PEMDAS, the quadratic squares, quadratic equations, and coordinate geometry. For trig, or not really trigonometry, but the very basic triangle geometry, there's the Pythagorean theorem and the Pythagorean triples and the special right triangles. These are covered in the Kaplan textbook and the Cliffs Notes textbook both. But I put them on the chart for them to memorize with their other formulas as well. We have the different rules for exponents, all of the formulas for distance, rate and time, interest, permutations and combinations, statistics formulas, including a step-by-step description of how standard deviation works, the basic probability formulas, combined work formulas, percent change, and graphing a circle. And then on the back side, you can print this out as a two-sided piece of paper, are the keywords for your word problems. One moment. Keywords for your word problems, your geometry formulas, of which there are numerous geometry formulas, a small key for the geometry section specifically, and then what a lot of students worry about disproportionate to its presence on the exam are measurement conversions. I have included the English and the metric here. The textbook provides equivalencies between them, but the conversions between measurements are significantly less important. Once they've got the basic English system memorized, and most native English speakers, in my experience, don't even remember how many feet are in a mile, then they'll be really very solid on the measurements. So now I'll take us back to the web page. Here we have the orientation screen. And, oops, go back to test prep. All right, let me pause for a moment while I scroll because it can be dizzying. So once you get past the chart, make these notes to yourself to remind the students. It's very important that they memorize the chart to note the different categories of information that we recommend for the students to memorize. And so really, as an instructor, you should have them memorized as well. That includes the numerical equivalencies, order of operations, the formulas for coordinate geometry, for geometry of 2 and 3 dimensions, and the keywords for the word problems. Note also this is what I was talking about when I was saying the keywords and the turnaround words. For example, subtract 3 from 4 means 4 minus 3, because the word from, it switches the order. It's a turnaround word between the 3 and the 4. And this only happens in subtraction and division problems. It's a feature of English grammar that sometimes those prepositions can reverse the word order. So look at those examples carefully. There is also a Cliffs Notes book on word problems in the library here on AEI's campus. I think it's in the main library at the moment, that you can look at. You can also probably find a copy online, Cliffs Notes for word problems, to discuss the nature of those turnaround words and how to best instruct your students to handle them. So note that the way both exams increase the difficulty of their math problems is to increase basically the number of subjects involved in each question. For example, a simple or easy problem might require only arithmetic, only algebra, or only statistics to solve. But a difficult problem might first require you to calculate a probability and then determine a set of combinations, or the other way around, you figure out the number of combinations and then what probability you are of becoming one of those combinations. So a good test prep instructor will elucidate, you will make clear these aspects of test creation so that students understand that a higher difficulty in mathematics tends to just be based on higher levels of complexity as far as test preparation goes. Not necessarily as far as like actual mathematics goes, but as far as test preparation for mathematics goes. That's what we're looking at, is higher levels of complexity more often than not. And then to complete this video, I will talk about our primary strategies for the math section. These are memorization, involving, of course, memorizing those formulas, vocabulary, equivalencies, and so forth, so that you can move as quickly as possible, and also be really automatic to recognize what you're dealing with in a given math problem. The process of elimination, where you rule out obviously wrong answers and guess from the remaining choices. So make it explicit to the student that when there are 5 possible answers, then your chances of guessing correctly are only 1 out of 5. That's 20%. But if you can reduce it to just 2 answer choices that are highly likely, you've got a 50-50 shot, a 1 in 2 or 50% chance of getting the answer right. So process of elimination is really important for us. Back solving, also known as plugging in the answers, depending on whether you're reading a Princeton book or a Kaplan book, is where we try the answer choices that have been given to us and plug them into the question to see if any of them work. We always start with the middle value to see, do we need to go higher or lower next. The fourth strategy is picking numbers using FROZEN. You try to plug in numbers of your own that are relatively simple to calculate, such as fractions like 1/2, 1/3, repeats of any numbers that appear in the question itself, like if the number 12 is in the question, you try to plug in 12, ones, +1 and -1, 0, extreme values. I like 100 is a good round number to use as an extreme value, and try numerous calculations with that. And of course, some other negative numbers such as -3 or -5. You want to try as many as you are allowed to see, do I need more information? Because sometimes not enough information is an answer choice. Or can you consistently get the same relationship and therefore you know for sure what the answer is going to be? The fastest evaluation, you always start with +, -1, 0, and 1/2, and that'll give you the quickest information. But sometimes questions are going to say it has to be an integer, in which case you cannot try a fraction. So the last strategy we usually emphasize is to take notes. Write down what it is you're looking for, as well as whatever information the problem is giving you, and draw your own diagrams or tables. This will help you better understand the question and solve things more quickly, as well as keeping track of where you might be making a tiny mistake that could result in you just getting the wrong answer. You should never read a single question without pencil and paper to take notes. I always try to emphasize that. So I'll stop there for this video. I'll see you in the next one on the GRE verbal section.